Hi everybody, this video today is going to be the first video in Unit 4, which covers functions. So today we're going to be talking about relations and functions. Let's go ahead and get started. So first of all, some definitions. A relation, we talk about relations and functions in algebra. A relation is just a set of ordered pairs. So just some xy coordinates. Any set of xy coordinates would be called a relation. Then within a relation, we have a domain, which is the x values, and the range, which is the y values. You can remember the difference because they're kind of alphabetical. In other words, x comes before y, just like d comes before r. So that's one way you can keep them separate. Okay, there are several different ways to represent a relation. We can talk about it in terms of ordered pairs. We can remember that's what a relation is. It's a set of ordered pairs. We can put it in a table, we can make a mapping diagram, or we can do a graph. We're going to cover all four of those today. So when we talk about domain, remember domain is our x values and range is our y values. These little, I call them kind of curly braces, they're kind of like parentheses. They just keep a bunch of things together is what they do. So the domain are the x values. So we have a -3, we have a -2, a 1, a 3, and another -3. But we don't need to list it again. We only need to list it one time. So there's the domain. The range are the y values. I usually like to start at the lowest number and work my way up. So I might start with a -4 and then go to 0, 1, 2, 5. So those are all my y values and they make up the range. Okay, we can also put these in a table. Remember that these ordered pairs, these are my x values, these are my y values, x, y, etc. So I'm going to take a second to put each of those in there. In other words, my first point that I have is -3, 1. And then I can put in a -2, 0. And then I can do a 1, 2, etc., etc. And so that's another way that I can represent my data. And depending on what your objective is, you might represent data in a different way. So sometimes, depending on what it is, sometimes the table makes more sense. Sometimes it makes more sense to put it in a graph or so forth. So we have a variety of ways, but each one kind of makes sense in different situations. In a mapping diagram, we typically put our x values over here in this oval, and we put our y values over here in this oval. So I'm going to do that. All these numbers that I had in the domain, I'm going to put in my x, and everything I had in the range, I'm going to put in the y. Now you guys have seen these before. This is where we then start matching them up, like which one goes with which. So like -3, it goes with the 1, and -2 goes with 0, and so forth. And so I draw a line and I match them up. So, I just went point by point. The -3 goes with the 1, but the -3 also goes with the 5, right? Because we had one of them here and we had one of them here. So I had to do that. And so what the mapping diagram is, it starts to give us some warning. Because these two, they both go to the 3, but yet they go to different places, that should set up some warning signals in our head that something is not quite right. And it's true, something's not quite right there. So we'll talk about that as well. But let's just keep going with where we're going. I know that the notes didn't come out really well on this graph, but let's try to graph these points. And we can graph them from a table, or we can graph them from coordinates. I actually think it's easier for myself just to visually to see it in a table. And again, it's kind of hard to see because your copy is not great, but there are axes in here. So -3, 1 is going to be -1, -2, -3, and then up to 1 like that. So over here, that was the -3, and then that was 1. So -2, 0 would be here. 1, 2 is going to be over 1, and up 2 is right here. 3, -4 is down here, and then -3, 5 is up here. And so I can graph each of those points and put them on a coordinate grid, and that also gives me some information. And so again, we have a variety of ways, but each way that we do it gives us a little bit different aspect, lets us see it in a different light. So we talked a minute ago about domain and range. Domain is your x values and range is your y values. We also can talk about input-output. And input is typically a word that we use with x values, and output is a word we use with y values. And so a function is a specific kind of relation. It's like a subset of relations. And the specific thing is that every x has only one y. And so that's an important thing to remember with functions. Every x has only one y. Okay, in this next section, I have some examples of what could be a function and what couldn't be a function. So I just kind of picked some random examples, and I used our names from our class. So here we have a list of some things that are functions and some things that are not functions. So think about your name and your student number. Can you possibly have two student numbers? No, you can't have two student numbers. In the minute I'm going to show you these, I made up the numbers. They're not really real numbers. Same thing, well, not the same thing. Think about your birthday and someone else's name. So like, can two people have the same birthday? Yeah, they can. So since two people can have that, it is not a function. So let's take a look at what we did here. So think of this like an XY table, or we can also think of it as a mapping diagram and kind of look at it that way. So like, again, these are not real student numbers, so don't worry about that. You know, Sage has this student number, Deacon has this, Carolyn has this, Angel has this, Peyton has this. There's no person who has two of the same number, right? Or no one shares a number. So that would be a function. What would not be a function is something like a birthday corresponding to a name, because again, January 1st is Haley, December 2nd is Dianara, October 3rd is Grace. Now November 4th, maybe both Landon and Luke, I had to pull some from a different class because we ran out of names, both of them have the same birthday. And so November 4th goes to both people. Therefore, that would not be a function because it has this little kind of sideways V where the number November 4th is going to both people. Think of some other ideas. What are some other ones that could be a function? So, well, for one, we could also swap this and say student number has only one person that goes with it. I was about to say phone number, but it's possible you and your parents share a phone number. So if you and your parents share a phone number, then that would not be a function. But if you have your own phone, that would be a function. So things like that, anything that like is unique to that one thing, that would be a function. Anything that could possibly like double up some way, that would not be a function. Okay, so let's talk about what is a function and what is not a function. Remember the definition is that every x has only one y. And so I'm going to keep that in mind as I look at these. As I look at these problems, I'm going to think of, does every x have only one y? So I'm going to specifically look at my x values. I have a 5, a 3, a 2, a 0, and a -1. None of them repeat. They each have only one y. And so number 1 is a function because every x has only one y. Let's look at the next example. Okay, again, I'm focusing on the x's because every x has to have only one y. -2, 0, 2, 3, and 2. Now hang on a second. We had two different 2's show up, this one and this one. Okay, this one has a -4, this one has a +4. That is not a function. So take a second to write this down. That this one is because every x has only one y. This one is not because there's this repeating thing, that the 2 shows up in two different places and has two different values. So that is not a function. Okay, so let's do some more of those. We want to look to see, does every x have only one y? So once again, when we start looking, we start focusing on our x values. And in this table, I'm looking and I see an x here and I see an x here. However, they have the same value. Like on this one over here, it was different, a 4 and a -4. This one actually is a function because every x has only one y. Well, what about the 3? Well, it just has one. It has the number 1. This has number 1. This has number 1. The other ones that are in here are meant to like throw you off. They're not, it doesn't matter. We're just paying attention to whichever repeats over here. So even though the y's repeat, we don't care about that. We're looking at the x's only. All right, we look at the next one. Same thing. We're going to look at the x values, which now we've changed the name to input output, but that's still x and y. All right, once again, I see a 4 here, and I see a 4 here, and they have different numbers. This one has a -3, and this one has a 2. So this one is no, because the 4 has 2 different outputs. And so if it has 2 different outputs, it is not a function. Okay, and then again, these mapping diagrams. What we're looking for is this little point. Okay, this one is not a function, because a -1, it goes to 0, but it also goes to 7. It cannot be a function. And the last one here, again, we're looking for that, like that point here, which we do have a point here, but that's actually okay, because what we need to focus our attention on are the x values, and each x has only one line coming out of it. So this one is a function because every x has only one y. Okay, have you learned the vertical line test? That might be something you've learned before. It is a test to see if something is a function. If something is a function, then its graph, we can use this vertical line test. And when we do that, the vertical line can only touch the graph one time. All right, I'm going to use this red line as my vertical line test. So as I move this across the line, it's only touching at one place here. But as I move it, now here it's touching it in 2 different places. And here it touches it in 2 different places. But here it only touches it in one place. This one is not a function. And the reason it's not a function because the vertical line touches it more than once. So like if I leave it right here, for instance, then it's going to touch it in both of those places. And so anytime you can find at least one place where it touches it more than once, that means it does not pass the vertical line test, and that means it is not a function. Okay, let me try bringing my red line over here and seeing what happens over here. This time, they're not connected, and that's okay. They don't have to be connected, because remember, a relation is just a collection of points. They don't have to be connected. So I can look at this as a function or not and decide if it's going to be a function. As I move it over, it only touches it there once, that's good. Only touches it there once, that's good. But right here, it touches it twice. So once again, this one is not a function because the vertical line touches it more than one time. Okay, I decided to type it out for you because my writing was getting awful. So yes, this is not a function because the vertical line touches it more than once. All right, one more time on this last one. So I'm going to take this line and I'm going to run it across and see if there's any place where it touches it more than once. So I'm going across, it's only touching it one time, only touching it one time. Everywhere I go, it's only touching it one time. There is no place where it like overlaps itself. And so this one is a function. Okay, so this one is a function. And I said because the vertical line only touches it once everywhere. Anywhere I drag that line, only touches it once. So that is a function. For me, the vertical line test is the easiest. I guess I'm just a visual person, and I feel like that makes sense to me. Okay, this last question kind of turns the whole thing upside down. So rather than asking us, is it a function or not, we're giving one, and it says, look back at example number 1. So this is one that we already decided is a function, because every x has only one y. So now we're being asked to think, can you think of an order pair that would break the function? Like if we added another point in there, what's another point that we could add in that would make it not be a function? Well, we have to think about our x values and then think of a y value that would make it not a function. So in other words, I already have a 5 that goes with -2. What if I said 5, 0? Okay, that would make it not a function. Or maybe I wanted to use the 3. It already has a -5, so maybe I say 3, 1. That would make it not a function. Or maybe I want to take this -1 and I want to make it instead, I'm going to make it a -1, 10. That would make it not a function. So anyone that you can come up with that would have the same x value but a different y value, that would make it not a function, and that would like break the function, make it so it's not a function anymore. All right, that is a conclusion of our video for lesson 4.1. on relations and functions. We will talk about this and work on it some more in class tomorrow.